time. We feel it passing every second. We grow older, memories fade, moments disappear forever. But what if time isn't what we think it is? What if the past and the future still exist? And what if, under the right conditions, time itself can be traveled? For centuries, time travel was nothing more than science fiction, a fantasy found in books and movies. But today, modern physics tells a very different story. Because according to science, time travel may not only be possible, it may already be happening. Everything changed in 1905 when Albert Einstein introduced the theory of relativity. Before Einstein, time was believed to be absolute, a constant ticking clock shared by everyone in the universe. But Einstein proved something shocking. Time is not fixed. It slows down, it stretches, and it depends on speed and gravity. This is called time dilation. The faster you move through space, the slower you move through time. Astronauts aboard the International Space Station age slightly slower than people on Earth. This is not science fiction. It has been measured. It has been proven. In other words, time travel to the future already exists. If you could travel close to the speed of light, a few years for you could mean centuries for Earth. You would return to a future where everyone you knew is gone. Time, it turns out, is not a river. It is a landscape. Einstein also discovered something even stranger. Gravity doesn't just pull objects. It bends time itself. The stronger the gravity, the slower time moves. Near a black hole, time nearly stops. If you stood near its event horizon while someone watched from far away, they would see you frozen in time. But for you, time would feel normal. This means one terrifying thing. Black holes are natural time machines. Travel close enough, and you could leap thousands of years into the future. But there is a price. The gravity would tear your body apart long before you ever returned. Traveling to the future seems possible. But what about the past? This is where physics begins to break down. One idea involves wormholes, theoretical tunnels connecting two points in space-time. If one end of a wormhole moved faster than the other, time inside would desynchronize. In theory, stepping through it could send you back in time. But there's a problem. Wormholes are unstable. They collapse instantly unless held open by something called exotic matter, a substance that may not even exist. And then comes the biggest problem of all. If you travel to the past and change something, do you erase yourself? What happens if you prevent your grandparents from meeting? You would never be born. But if you were never born, you couldn't go back in time to stop them. This is known as the grandfather paradox. To solve it, scientists proposed two ideas. The multiverse theory. Every action creates a new timeline. You don't change your past. You create another reality. The self-consistency principle. The universe prevents paradoxes. No matter what you try, history will always unfold the same way. In other words, the universe may not allow time travel to break itself. There have been strange cases that challenge our understanding of time. In 1971, physicists flew atomic clocks around the Earth on airplanes. When the clocks returned, they showed a difference in time, exactly as Einstein predicted. In quantum physics, particles sometimes behave as if they move backward in time. And in deep space, some cosmic rays appear to arrive before their source event is observed. Science cannot yet explain these fully, but they suggest one thing clearly. Time is not as simple as we think. So, is time travel real? According to physics, traveling to the future? Yes. Traveling to the past? Uncertain, possibly forbidden. But one thing is clear. Time is not a straight line. It bends, it stretches, and under extreme conditions, it breaks. Maybe one day humanity will unlock its secrets. Or maybe time travel exists, and those who discovered it chose never to return. Because some doors, once opened, can never be closed again.